Good evening, good evening, good evening. My dear J Warriors, welcome aboard to the part 1 physics revision of your book 1 of class 12th NCRT physics revision just before your board examination of CBSE 2026. Welcome aboard. Let's begin with your Captain Shreyas. I'm going to revise the theory quickly. We are going to go through all the important points. This will be a very, I would say, impactful, powerful session, and we won't keep it very long because I know your board exams are there, and self-study, your practice, handwritten practice matters more than anything else. So many of you, I know, during board exams you must be doing this. Correct me if I'm wrong. You'll be taking some book like this, and you will be huh, hmm uh, if the positive work is done by system, then thermodynamic losses in the volume must increase in the light of the above statements. So if this is what you're doing, guys, this is wrong. And then you read it, and then you close your eyes. Okay, yes, this is what the definition of electric charge is. This is the definition of that. This, if you're doing that, that is wrong, guys. That is not the right way of revising things. Open up a notebook, write down the points. Need not have to be neat about it. It's just trying to recollect in the written form. If diagrams, charts, graphs are there, draw it roughly. No need of careful planning and right drawing it neatly. Just to the point. Okay, that is how you should practice before the board examinations, right? So this is going to be an impactful session. Welcome aboard, everyone. Hi, Max Planck. Wow. Hi, Shrikar. Welcome, Sanjana. We want PYQ session for April attempt. Definitely it will come. Hi, Sudeep. Hi, Tarun. The session might be around 2 hours or I would say 2 to 3 max. Seeing Shreyas Sir after Pathfinder. Oh my God, that's a long time. Hi, Adi. Welcome aboard, everyone. And I hope you guys have smashed the like button right away, right now. Yeah, hi Sabri, hi Level Up, welcome aboard. Hello, Lakshmi. Good evening, good evening. Nice to see all of you. All right, so it's time to start the session. Okay, so like I said, some revision, theory points. To the point, I'm not going into detailed explanation because we are 2 days before the exam. Second thing, we'll do practice questions also, 1 mark, 2 mark, 3 mark. So those kind of questions also we'll practice just so that you are in touch with the kind of questions that might be asked. All right, so let's begin with electric charges. Today we are doing only book 1. Tomorrow we'll do book number 2. Okay, part 2 we'll do tomorrow. So let's start with electric charges and fields, all the important concepts. We start off by the concept of electric charge, which is a fundamental intrinsic property. This is a fundamental, I would say, intrinsic property. Intrinsic means it is a part and parcel of existence of that matter. Just like mass is an intrinsic property, just because of its existence it gets it. It's a scalar quantity. SI unit is coulomb, but it is not fundamental quantity. Remember the dimensions. The dimensions are not coulomb, rather it is ampere multiplied by time. Okay, so it's not a fundamental physical quantity. Okay, there are different ways of charging. One is friction, induction, and conduction. Friction, imagine you take a comb and rub on your hair, and then it attracts bits and pieces of paper. That is friction. Then induction and conduction. Induction means you are bringing a charged body close to another body, you are not touching it, so it induces charges in the other body. That is induction, and you will see that the body will get polarized. Positive, negative charges get separated, it gets polarized because of induction. You bringing a body close by. Conduction, conduct, you actually touch. You take a body, touch it to another body, the charges flow from one side to the other side. That is conduction. So standard, they might ask, these are very common questions. Explain the, in brief, 2 marks or 1 mark, the main properties of charges. Depending on the marks, you can elaborate more or keep it concise. The main properties are addition of charges. Because it is a scalar quantity, you can just add the charges with the sign if it's positive or negative. Okay, number 2, charges are conserved. So if you have a system and there is some 5 coulomb, 10 coulomb, 100 coulomb charge, no matter what you do, okay, you will always see the net charge is always going to be conserved. Next is quantization of charge, which is basically charges are always integral multiples of E, where E is your basic charge. Remember, electronic charge, which is 1.6. into 10 to the power minus 19 coulomb. So all charges have to be integral multiples of this. All right, so this is one thing. Just 1 second, my AC. Just 1 second. Just 1 second, guys. Yeah. Okay. Next important thing is the Coulomb's law, where the attraction or repulsion between two charges is given by Coulomb's constant charge 1, charge 2 divided by the separation r square. The Coulomb constant, which is 1 by 4 pi epsilon naught, has a value of roughly, 9 into 10 to the power 9. That Coulomb constant is approximately 9 into 10 to the power 9. Remember that. Okay, that epsilon naught is permittivity of free space, and that permittivity has a value of 8.85 into 10 to the power negative 12. So these are some of the important points in the first few pages of NCERT, isn't it? All right. The session will be around 2 hours, max to 3 hours. Okay, we are going to keep it compact. The force between multiple charges. Now, when you have two charges, then you use this formula K Q1 Q2 by R square. But imagine multiple charges are there, then you superimpose all the forces. So, charge 2, charge 3, charge 4, charge 5, all of them will apply the forces. Each one will be having similar form K Q1 Q2 by R square, K Q1 Q2 by R square. But the pairing of the charges will change and the distance will also change. So, the distances are different and the pairing of the charges, charge 1 with charge 2, charge 1 with charge 3, charge 1 with charge 4, charge 1 with charge 5, like that, and all their directions could be different. So you need to take the vector addition, just don't add them. Some forces might partially cancel, some might completely cancel, some might add, some might partially add. Basically use laws of vector addition to find the net force. That is called as superpositioning principle. And when they ask you explain superpositioning principle, show one charge, show the forces, draw the vector addition and the resultant one, and then explain okay, force 1, force 2, force 3, force 5 by all these charges added together gives me the net resultant force acting on that particular charge. That is your superpositioning principle, right? Next important thing, the distribution of charges. These are important pointers, quickly going through it. Linear charge, surface charge and volume charge. A linear charge is like a wire, surface charge is basically like a sheet, a volume charge is like a sphere, cube, whatever, okay, which has complete charge within that volume. So a linear charge density, usually the symbol is lambda and expressed as charge per unit length of that wire. Surface charge density, so if you have a sheet, it is charged, the charge per unit area of that sheet is called sigma, coulombs per meter square will be the unit. Volume charge density, the symbol is rho, it will be the charge per unit volume like a sphere, okay, and unit will be obviously coulomb per meter cube, keep that in mind, okay. Now, each of these systems produces forces and fields around them, and the formulas are going to come, in the next few pages. Like, for example, if you have a linear charge density, the electric field formula due to a long wire, what is that electric field, guys? Due to a long wire, it is nothing but 1 by 4 pi epsilon naught. You have lambda, right, into lambda divided by basically r over here, and then there is the number 2 also over here. So 2 lambda divided by r due to a long wire. So same way we will see for the sheet, and even volume charge density also we'll see in the next few pages. Anyways, what is electric field? They might definitely ask you define electric field for 1 mark, or maybe as a objective kind of question. So force acting on a unit test charge, the force acting per unit positive test charge is the electric field. Newton per coulomb is the SI unit. It is a vector quantity. The direction is same as the direction of the force on the testing charge which is being kept near the other charges. Okay, so you can mention it is a vector, mention the unit, write down the formula, write that line, it is the force acting per unit test charge. You will get complete 1 or 2 marks depending on the marking scheme. Next, electric field due to a point charge. So just like the force formula has k q1 q2 by r square, here q1 q2 will not be there, only q will be there. So it will be Coulomb constant q divided by r square is the electric field. No q1 q2, just a single q. Direction of the field is radial from that charge, pointing outwards if q is positive and inwards if q is negative. So if you have a positive charge, then the field is outwards, but if the same charge is negative, then the electric field is directed inwards towards the negative charge. That's the direction of the electric field. Yeah. All right. Very good. Hi, Salatim. Welcome. Yes, everyone. The paper will be fully based on competitive application questions. All right. If you want me to conduct some questions on that, maybe we can do that tomorrow if possible. Let's see how it can be done. Electric field lines, a line of force. Electric field is different, electric field lines are different. Electric field, so read the question carefully. People make these stupid mistakes. Okay, these are silly mistakes. Electric field lines, it's the diagram. Okay, so electric field lines are those lines of force which are basically curves or straight lines, so that the tangent at every single point points in the direction in which the electric field is directed. It gives me the direction of the electric field. So at one point electric field is here, so you continue and you reach the new point, the electric field will be at a new direction. So you continue, you reach the point, again the electric field will be at some new direction. So if you join those points along the tangent, you get the electric lines of force, which are also called as electric field lines. The tangent drawn gives me the direction of the electric field. There are some properties. So if it is a 3-mark question, you might be asked to explain also the properties apart from the definition of electric field lines. And when such a 3-mark question will come, you should also show the diagram of a positive negative charge. Show for positive charge the electric field is outwards, negative charge the electric field is inwards. Showing this will add value to your answer. Okay, diagrams always are important when the marks are higher. Okay, anything more than 2 marks, you should draw a diagram if there is a diagram or a chart or a graph, whatever. Field lines start from positive charge and they end at a negative charge. If there is a single charge, then they will never end because they will terminate at infinity. That is obvious. So field lines will always start from positive and at negative. When there is no charge in that region, then electric field lines can be taken to be continuous curves without any breaks. So only the field lines can start or end on a charge. So when there is no charge around, it is always a continuous line. There will be no break. It is not discontinuous. No two field lines can ever intersect because then the tangents will be two in nature, which is not possible. Electric field lines do not form closed loop. This follows from conservative nature of the field. So electric field lines will never start and end at the same point. That is not going to happen whenever it comes because of a charge. All right. So they will either start and end at two different points or end at infinity, but never come back again to the same point. Okay. That is not possible. They will not form closed loop. Magnetic field lines can form closed loops. Keep that in mind. So showing these diagrams can add value to your answer. Like for a positive charge, it is radially outwards. Positive will give out. Negative, it is a sucker. It is going to suck out all these electric field lines into it. If you have two positives, then both of them will give electric field lines. But remember, they cannot intersect. So you can see they will repel from each other. Whereas a positive and a negative, the field lines will originate from the positive and it will terminate on the negative charge. So originate, terminate, originate, terminate, originate, terminate. So that is how the field lines will look like. You might also be asked, explain in 1 mark or maybe maximum for 2 marks, how will the field lines look like for two positive charges or one positive, one negative charges or two negative charges? Quite possible. So freehand drawings can be asked. You never know. Okay. Yes, we'll be completing the entire book 1, man. Don't worry, it is not a big deal. All right. Next is electric dipole. Dipole. Poles, polarity is positive, negative. Di means two. So one positive, one negative, but equal amounts. Then it is called as an electric dipole. You have so many examples of polarities, dipolarities, like a simple molecule like hydrogen chloride or NaCl. These are dipoles, because an equal amount of positive and negative charge is being created and separated by a small distance. So these molecules then are called as polar molecules. Okay, because there are two polarities of equal amounts which are being now introduced inside that kind of structure, or you can say that molecule. All right, now the dipole strength is measured by electric dipole moment, whose symbol is small p. It is a vector quantity. Yes, it is a vector quantity. It's always from negative to positive. Students usually make a mistake. See what happens if you are positive, negative, electric field goes from positive to negative. That is electric field line. But dipole moment goes from negative to positive. So keep that in mind. This is a common point of mistake of many kids. Okay. Electric field comes from the dipole. It goes from positive to negative. That's obvious. But dipole's moment, which is a new vector quantity, goes from negative charge to the positive q charge. The value is charge multiplied by the separation, the distance. Now, students again get confused between A and 2A. A is half the length, 2A is the total length. So, the actual distance between the negative and the positive charge is given to you. This is negative charge, this is positive charge. Then that itself is the 2A length. It is not A length. So, in the NCERT book, they use the total length as 2A. Semi length or half length is A. Keep that in mind. Okay. Right. So it is having the SI unit of coulombs into meter. All right. That is also obvious because coulombs is charge, A is length, so meters. Now there are electric field calculations or potentials due to these dipoles on two different points. One is along the line joining these dipoles, which is also called as the axis. And the second one is basically when you are perpendicular to it. So for the axis, there is one thing, and also for the equator. I think it is not mentioned here. I'll just mention it. So if you are on the axis, so if, for example, this is your dipole, and that means this is negative charge, this is positive charge, and you are on the axis, then the electric field is exactly in the same direction. Electric field on the axis in the same direction as that of the dipole. So you will see the vector E and P vector, they both are in the same direction. There is no negative sign or anything. And the value is given by 1 by 4 pi epsilon naught is standard. You have 4qa divided by r cube of the distance. This is basically r, the distance between the point and the dipole. Okay, cube of the distance, not square. Keep that in mind. And there is 4qa. Alternatively, you can remember this as, if you want, 2 times of the dipole moment, because q into 2a is a dipole moment. So 2 times of p will be q into 4a. So 2 times of dipole moment is there in the numerator side. Similarly, if you go on to the equatorial side, then the electric field is exactly opposite. So electric field on the equatorial side will be exactly negative of this quantity. So you will have 1 by 4 pi epsilon naught will be there. R cube is also there, R being the distance from the dipole to that point. And on the numerator side, it is not 4, it is just 2qa. Basically, just a single dipole moment, P. Just a single dipole moment, P is there. Okay, negative sign indicates the field is opposite to that of the dipole moment. Yeah, all right. Everyone, very good. NCRT line by line, very helpful. I'm so glad, man. Yeah, that's the whole purpose of that session. It's there still on the channel. You can see my recordings from last year. I didn't want to repeat the same thing. I'm seeing even new fresh comments on those sessions even last couple of days. Okay, all right, perfect. Let's move on. Let's move on to the next thing, which is basically the torque on the dipole. See, whenever you have field and there is a charge, the charge experiences a force, because field is force per unit charge. So if you place some charge, that charge will experience force due to the field. Now a dipole has two charges, so it will experience two forces. But since the forces will be opposite because the charges are opposite, so you will see they create a couple, and that couple force basically never creates translation, it only creates rotation. So there is torque by the dipole, not any net force. In fact, the net force will always be zero, because charge into field force here, charge into field force is here. These two forces will cancel, but they are not along the same line, so they will create a torque on it, given by P cross E. P being the dipole moment, E being the electric field, cross product to denote torque being a vector quantity. Yes, so if the dipole moment is like this, electric field is like this, so dipole moment cross electric field will be the torque acting on that dipole. It kind of makes sense because it will try to rotate like that. P vector is here, negative to positive, electric field is like this, so P cross E, it's a cross product. If you want the magnitude of it, it will be just P E sine theta, dipole moment into electric field into sine theta. All right. Yes, when theta is 0, that means dipole moment is parallel to the electric field, torque is 0. Even for 180 degrees, sine 180 is 0. So dipole moment is opposite to the field, the torque is 0. But the torque is maximum when the dipole moment is perpendicular to the electric field. Keep that in mind. Okay. Yeah, VIT triple E PYQs will come, man, later on, not now. First, let the board exams get over. Okay. Okay, perfect. Sir, are you getting old? I mean, of course, I think even you are getting old. So if you are talking about the rate of getting old, it is the same, man. D old of Shreyas Sir with respect to dt is equal to D old of what is your name, man? Max Planck. Yes, Max Planck. Okay. With respect to dt. If you want, you can also cancel out dt, and then you can also integrate this on both the sides. But the constants of integration will be existing if you are doing it the indefinite way, because we are born at different times, right? So maybe my initial condition will be different. That's all. Okay. So maybe my time 1 when I was born will be different. This is time 2, and then you can get the final time over here T3 and T4 over here. So you can integrate this also if you want to. Okay. So yes, the rate of getting old is the same, and everybody is getting old at the same rate. Yeah. Okay. Perfect. Next. Electric flux. Electric flux of the electric field is basically a quantity which measures how much of the field is passing and piercing through an area. How much of the field or the lines are piercing through that area. All right, great, perfect. Now that flux is defined as the electric field multiplied by that area. Yes, that delta stands for the area through which that field is piercing. So if more field pierces, more flux, more area is covered, more flux. Okay, but there is a catch in that. The dot product is there. That dot is not seen that clearly, so maybe I can put it like this, and this is actually a vector, so it is actually E dot ds. So electric field is a vector, area is a vector. Area vector means, remember, so if this is my area, you drop a perpendicular to it, that is your area vector, delta S. And maybe the electric field, might be at an angle to it, so that angle might be theta. So when you expand this, this will become E delta S cos theta, theta being the angle between electric field and the area vector. So sometimes electric field might be perpendicular to the area vector, so cos of 90 will become 0 and the flux can become 0. It's very much possible. Keep that in mind. Yeah, very good. No bro, I didn't take it serious, I was explaining it. Okay. Yes, next important thing, yes, it is a scalar quantity. Keep that in mind. It is a scalar quantity. Yeah, because it's a dot product. Unit will be, this is Newton per coulomb and then into area, meaning meter square. So Newton per coulomb into meter square. That is the unit of flux. Now Gauss law. Gauss law says that instead of measuring the flux through just some random area, you take the complete area. But complete area means closed area. So you leave no patch. You completely enclose a system of charges or charge, then that net flux will always be the total charge, numerical charge inside, divided by epsilon naught. Now when I say total numerical charge, some charges could be positive, some could be negative. So you add them algebraically, that is what the Q will stand for over there. Using that, you get the electric field for different geometries. First one being the line charge, linear charge density. So it is lambda by 2 pi epsilon naught r. Or if you want to make it 4 pi epsilon naught r, you need to multiply the number 2 in the numerator. So 2 lambda by 4 pi epsilon naught into r is the electric field due to a line charge at a distance r. Yes, it is inversely related to r. So you can see electric field for different geometries has different relationships with distances. Like for a dipole, it was inversely related to r cube. For a point charge, it is inversely related to r square. For a line charge, it is inversely related to r. Keep that in mind. But if you take a sheet, it is not even dependent on that r. It is independent because the field becomes constant and it is just sigma by 2 epsilon naught. Sigma being the charge per unit area and divided by 2. Yes, the field goes in both the directions. That's how you remember that the number 2 comes in that formula. Okay, sigma by 2 epsilon naught. Next, for a shell, well, if you're inside the shell, then the charge enclosed inside the shell is 0, the field comes out to be 0. So whenever you have a shell like structure and the charges are on the periphery, if you go inside that periphery, inside that shell, nowhere will you get any kind of net electric field. But if you go outside the shell, the entire shell behaves as if it is a point charge, as if the charges are concentrated at the center, and the electric field will be k q by r square, regular formula, just like for a point charge it should be. Is that right, everyone? Yes, perfect, amazing, awesome. Pritija, when maths paper will come, then maths ma'am will come. Okay, now physics paper is there, so physics sir came. When chemistry ma'am will come, when chemistry will be there, because after physics, chemistry, then maths. Is that right? Okay, so let's solve some questions. Electric lines of force about a negative charge R. Come on, I want everyone to spam the answers in the chat box, guys. Area vector and angle made by the plane. Okay, I will help you. Who is that? Nitesh. Okay, I'll explain that doubt. See, this is a very good doubt you asked, Nitesh. See, whenever you have an area, right? Area vector is always perpendicular. That area vector is always perpendicular to the area. This is area. This is area vector. That are two different things. Area. This is area vector. The electric field might be making some angle. Maybe let's say this is the electric field. This is the electric field. Now, if let's say, for example, this is 30 degrees, it's obvious that this angle will be 60 degrees. It's a complementary angle. So, if they tell that electric field makes 60 degrees with the area, this is what it means, because actual area it makes 60 degrees. So, naturally, with the area vector, it will make 30 degrees. If they explicitly mention about the area vector, then they will say like this: the electric field makes 30 degrees with the area vector or the normal drawn to the area. That's completely different. If they just mention with the surface, then it is 60 degrees. If they mention with the normal or the area vector, then it is 30 degrees. Is that now clear? But in the formula for the flux, which angle will you consider? You will consider 30 degrees, not 60 degrees. Okay? That angle between the normal and the field. All right, very good. Yes, option C, radially inwards. We are talking about, I think, a negative charge. So whenever you have a negative charge, the electric field lines are radial and they are inwards. So option C is absolutely the right answer, my dear warriors. Perfecto. Next question. For an isolated system, it is possible to create or destroy a charged particle, but it is not possible to create or destroy what? Answer in the chat box, spam it. JEE second attempt, I will help you, man, but your board exams are going on. I'm seeing everybody everywhere is just watching either PUC boards or Maharashtra boards or IP or Tamil Nadu state board or, CBSE board. All these videos are now running because your board exams are there. So as soon as the board exams are over, obviously second attempt preparation will start. Okay, don't worry. Yeah, option A or B, net charge of the system or charge on each particle. Yes, net charge on the system cannot change. Charge on every particle can change. Maybe one might lose, one might gain, but net charge will not change. A region surrounding a stationary electric dipole has, if you have a stationary electric dipole, what will it have around it? Positive and negative? Yes, it will have exactly electric fields around it. There is no question of magnetic fields. So electric fields only. Option B. Yeah, very good. Very good. Around 2 hours to 3 hours, man, not more than that. Okay. Next one. A positively charged rod is brought near an uncharged conductor. If the rod is suddenly withdrawn, then the charge left on the conductor will be, would have a positively charged rod. You brought it near a uncharged conductor. So it has got induced charges, positive, negative charges are separated. You move away the charge, the polarization will go away and immediately you will see no charge on it. Anyways, the net charge on the conductor will always be zero because you never actually transferred any charge because it was just brought near it. So actually net charge would never be changing. It would always be zero. Yeah, the charge left on the conductor will be zero. If it was brought near and touched to it, then positive charge would remain by conduction. So lot of students made this mistake and said A or B. Correct answer is C. Guys, you are making mistakes in objective questions, which tells you that some students become very overconfident after JEE Mains or before JEE Mains, think that okay, objective exam I too will get it. Don't do that. You cannot lose even 1 mark in these MCQs of CBSE. Okay, full marks you should get in this, not even one mistake. There is no negative marking, but you cannot lose marks over there. Three charges are there connected by strings. What is the ratio of tensions in string AB and BC? All right, if you talk about AB string, then let's talk about the charge A over here. That A charge will experience repulsion due to 2q force like this. So it will have K into Q into 2q divided by distance, which is D square. And this 4q and this will also be there. And that will be K into Q into 4q divided by 2D whole square. So that will be balanced by the tension between the balls A and B. So this tension AB will be the sum of both of them. You can see 4 and 2 square is 4 will cancel. This 2 will remain. So this tension will be, if you add both of this, it will be K Q square by D square plus K Q square, sorry, 2Q square by D square. So it will become 3K Q square by D square. That is for object A. Now, if you take this ball labeled C, on it, this charge is applying a repulsive force. How much will it be? K into Q into, sorry, not Q, it is 2Q. K into 2Q into 4Q divided by D square. And one more force between 4Q and Q. So that is K into Q into 4Q divided by 2D whole square. That will be balanced by the tension between these balls B and C, which will be equal to sum of both of them. So 4 and 2 square will cancel. 2 fours are 8. So it will become 8kq square by d square plus kq square by d square. So it will become 9kq square by d square. Now the question is really find the ratio of the tensions. Tension AB divided by tension BC. This is nothing but 3 times. This is 9 times. So it will be 1:3. So option B is absolutely the right answer. Okay, very good. Awesome, awesome, awesome. B, 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 B. Very good. Awesome. Somebody said D. No, man, it is not a D. It is option B only. All right, very good. 1 mark question, guys. 1 mark question. Show does the force between the 2 point charges. I don't think that word show is needed. Does the force between 2 point charges change if the dielectric constant of the medium in which they are kept increases? Well, and basically show might be like show that it increases. That's what the question might be. It's a 1 mark question, not a big deal. So 2 point charges, if the dielectric constant changes, so if the force between the two charges is asked, it will be 1 by 4 pi epsilon naught dielectric constant q1 q2 divided by r square. So as you can see over here, if dielectric constant, if the dielectric constant, all right, in which the medium kept increasing, yeah, if the dielectric constant increases, automatically the force will decrease. Yes, the force will change, and the answer for the change is it will decrease. It will decrease. So that is how you will write down the answer. Okay, I have not written it down properly, but this is what I mean when you practice at home. You don't have to write down full sentences. Now is not the time. So you just write down the key points so that you know what you're writing. Just don't say it mentally. Just don't visualize it. You are not meditating. You are not some uh, uh, crazy person who is going to visualize things right now before the board exams. That and all works for JEE, but not for boards, man. Okay. So don't mentally visualize. Don't mentally narrate yourself. Don't try to talk to yourself in your head. That is useless. Take a piece of paper, write it down. Okay. When you're practicing for board, especially. A charged rod attracts rod R, whereas P repels another charged rod Q. What type of force is developed between Q and R? Okay, think about it. Charge rod P attracts R. So if you have P and R, they are attracting each other. They are attracting each other. So it means if P is positive, R should be negative 100%. Whereas P repels another charged rod, P repels another charged rod Q. So if P is positive, Q should also be positive. Only then they will repel each other. So the question now is, what will happen between Q and R? So if you take Q and R over here, so this is R, and let's say this is Q. So this is negative and positive. Obviously, they are oppositely charged. So they should definitely end up attracting each other. So that will be your final answer. Okay, you can draw this diagram also. Teacher will be fully impressed. Yes, very nice. Awesome. Moving on to the next one. Which physical quantity has its SI unit, coulomb meter and Newton per coulomb? Come on, spam the answer in the chat box right away, right now. Spam the answers in the chat box right away, right now. Everyone. Come on, come on, come on, come on, everyone. Sir, would these slides be shared? Yes, man, I will share these slides. Not an issue. Yeah, I'll share the slides. Yeah. Coulomb meter is not linear density, man. Coulomb meter is dipole moment, P. And Newton per coulomb, force per coulomb, that is electric field. Yes. Be careful. Be careful. Dipole and electric field. Very good. Very good. Salatain. Yes, Lokesh. Very good. Pranav. Yes, Ashwin. Awesome. Awesome. All right. So, Srinivasan, maybe you can put up your doubts in the comment section. I will definitely answer it. Okay. After the session is over, let's not disturb the flow of the session. Don't spam like that, man. Define one coulomb. This can also come. Simple, simple things, but you can lose marks. Define one coulomb. A charge on a body is said to be 1 coulomb if the two charges experience a force of attraction or repulsion of 9 into 10 to the power 9 Newton when they are separated by distance of 1 meter. How does this come? Because this force is Coulomb constant Q1, Q2, okay, divided by R square. So imagine R is 1, K is 9 into 10 to the power 9. So the force will also be 9 into 10 to the power 9. And this charge is 1, this charge is also 1. So these two charges are 1 coulomb each if the force is 9, 10 to the power 9 for a distance of 1 meter. So that is the logic for this definition. Okay. Some students write, sir, when 1 ampere of current passes for 1 second, the charge is 1 coulomb. Although that is right, but that is not the correct definition what they are expecting. Okay, be careful. Yeah. All right. All right. Srinivasan, don't spam, man. Okay. Moving on to the next one. 2 marks question. A free proton and a free electron are placed in a uniform field. Which of the two experience greater force and greater acceleration? Well, if you talk about proton and electron, force is charge. Charge is either plus E or negative E. One is proton, one is negative. So that's it. Into the electric field. Field and E is the same. So which of them will experience greater force? Force is same. Force is the same magnitude wise. I'm talking about magnitude of the force. What will be different is the acceleration, because acceleration is force divided by the mass. So obviously we know mass of the electron is less, so denominator is less, so acceleration will be more. So acceleration of the electron will be more than acceleration of the proton. That is because mass of the electron is less than mass of the proton. That's the reason for it. Very simple, guys. Okay. Moving on. No two electric lines of force can intersect each other, and why? Very standard question. Okay, many times, but you have to write it properly with the diagram. Two marker question. The two lines of force never intersect each other because always start with the opening statement. Never start without that opening statement because it will add weightage. If they intersect, prove by contradiction. Because if they intersect, then there will be two tangents drawn. There will be two tangents drawn, which is not possible, as two tangents means there are two directions of the electric field. But electric field has to be unique. It has to point in one direction only. Hence, if they intersect, there will be two directions, which is not possible. Okay. So mention that, and you can draw two field lines and say this is not possible. The examiner will be super duper impressed even if you draw this simple diagram. Okay. Don't think like a conjure. Don't think like a miser. Don't think that I have to spend 1 rupee, 10 rupees are going out of my pocket for drawing this diagram. Be little bit liberal in drawing these diagrams. Okay. It is going to add impression. All right. Moving on to the next question. A particle of mass m and charge q is released from rest in a uniform electric field of intensity. Calculate the kinetic energy it attains after moving a distance between the plates. Very interesting question. Particle, mass, charge, release, rest, uniform field E, energy as it moves, some particular distance. Which formula, which logic will you use? Come on, think about it. Yeah. Which formula or which logic will you use? You need to find kinetic energy. That means you need to know the speed. To know the speed, to know the speed, what do you need to do? You need acceleration. For acceleration, you need force. And I think that is now possible. So if there is an electric field and if there is this particular charge having mass m, all right, and this charge will now experience a force like this, due to which it will end up accelerating in this direction. That force is charge multiplied by the field. The acceleration is force divided by mass. That means QE divided by m. And after moving some distance, a distance between the plates, okay. So using the equation, kinematic equation, V square is equal to U square plus 2A into the displacement. So my final velocity, I do not know, initial velocity is 0 because it started from rest. Acceleration is QE divided by M. Displacement is S. So therefore, from this V square will be 2QE S divided by M. But the question is kinetic energy. Kinetic energy is half M V square. So half M as it is. Just put these numbers 2QE S divided by M. M and 2 number will cancel. So the kinetic energy will be QE and S. That's it. QE and S. That's all. M got cancelled. 2 also got cancelled. So QES is the answer. QES, not 2QES. If you wrote 2QES, you will get 0 marks or maybe step marking depending on where you made the mistake. Maybe half a mark or 1 mark max, not more than that. Okay, keep this in mind. So draw these diagrams. I have written it in very short form. Guys, there will be more steps in between. Don't even write A is F by M. Write F is equal to MA. Then A is equal to F by M. How you should write is, you are explaining it to a 6-year-old. How should you write the paper? You are explaining it to a, do you understand? 6-year-old means what? First standard person. You should assume the main assumption. Assume paper checker is 6 year old. Only then you will write that correct. Only then you will write explanation properly, lengthy answers, or else you will be like, J student, sir, I calculated mentally, I wrote directly, sir, like this. Sir, I use different methods, sir. Force into displacement is the work done is equal to kinetic energy, work kinetic energy theorem. Many students, J advanced, QE into S directly, know their steps. Sir, work kinetic energy theorem, no, work is force into displacement, force is QE. So, all these things you cannot do, man, in boards. Okay. All right. Moving on. Next one. Electric charges and fields done. Okay. Electrostatic potential and capacitance. Let's go quickly, guys, to the revision concepts. Electrostatic potential is the work done per unit charge. Work done per unit charge to bring it from infinity to that point. That is electric potential. Electric potential due to a point charge is Coulomb constant. There is no 2, guys. Yeah, it is 1 by 4 pi epsilon naught, which is just Coulomb constant, into Q divided by R. R is the distance where you are measuring the potential. Potential is a scalar quantity. It is measured in volts. It is work done per unit charge. That means a volt is a joule per coulomb. That's the unit. A volt is a joule per coulomb. Now, if you talk about an electric potential at a point with position vector due to point charge with respect to the dipole, then the formula is, okay, forget this, I would say, remember this, it is Coulomb constant, which is just your K, your P, and then you have cos theta divided by R over here, R square over here. That's it. Yeah, that's it. So Kp cos theta divided by R square. That is your formula for your electric potential due to a electric dipole. What is theta? Theta is the angle made between the dipole and the point where you are calculating the electric potential. Yeah, please keep in mind there is R square, not R. Okay, there is R square. Keep that in mind. Okay. Next, if you have multiple charges, so due to a point charge, kq by r, due to two charges, one positive, one negative, k p cos theta by r square. Okay, that is a special case, electric dipole. But let's say there are two charges, but not a dipole, or 3 or 4 or 100 charges. Then electric potential due to first, due to second, due to third, due to fourth, basically superposition. Best part, it's a scalar quantity, so no need of directions. Only sign will matter. Okay. Next, electric potential energy, not potential, electric potential energy. When the term energy is used, then it is not per unit charge, it is just the work done. See here, it was per unit charge, right? The definition will change. It's just the work done in just accumulating the charges from infinity to that specific location or that specific arrangement. Okay, that is called as electric potential energy. All right. Now, the formula for electric potential energy is simple. It is K Q1 Q2 by R. K Q1 Q2 by R. It's not KQ by R. KQ by R is for potential. Energy means two particles at least. So K Q1 Q2 by R. Now, what is the relation between potential and potential energy? Just that factor of Q, nothing else, if you notice. Because over here, yeah, it is KQ by R. If you multiply one more charge, potential with one more charge, you will get potential energy. That's all. So that is the difference. For potential energy, the symbol is U. For potential, the symbol is V. So potential energy is charge multiplied by electric potential. So remember, potential is always per unit charge, energy is with that charge itself. Now, whenever you have a dipole placed inside an electric field, you will notice that the potential energy is negative P dot E, negative dipole moment dot electric field vector. All right. Electric potential on a surface, if it is constant, then such a surface is called as a equipotential surface. That means you locate the potential here, 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 everywhere the potentials are same. You join all those common points. That is called as an equipotential surface or a potential line. And for a point charge, concentric spheres are basically equipotential surfaces. Makes sense if you take a point charge here, 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 anywhere you go. along a sphere, the potentials will be same. You choose a different sphere, the potentials will be different, but on that sphere it will be same. But electric field at a point is always perpendicular to equipotential surface. That makes sense, because for a point charge, electric field will go radial, whereas the potential surface will be perpendicular like the spherical surface. So this is not just for a point charge, but for any system. Always surface and the field will be perpendicular, is in the direction of the steepest decrease of the potential. Meaning, say for example, this is an equipotential line, this is another equipotential line, this is another equipotential line. So you will see that the electric field will be perpendicular like this, and it will pass as if it is going towards the lower and lower potential in the steepest possible way, not like this. It will not chill and go like that. No, because this is a longer route, it will take the shortest route of decreasing potential. So it will always go from high potential, it will always go from high potential to low potential. Keep that in mind. Next, capacitance is charged by voltage. Totally how many slides? I'm not really sure, man. It must be around 130, 40 slides, I'm guessing. I will do one thing, guys. My throat is not helping me out today at all. That's the reason, in fact, last 3-4 days, I was also not able to take long lectures. I'll do one thing. I'll skip the theory part. I'll just directly do the questions part. Is that fine with you guys? Okay, I'll just show the slides quickly. Capacitance is charged by voltage. Capacitor is a device which stores electrical energy in the conductors, okay, when a suitable potential difference is applied, and the capacitance is defined as the charge stored per unit voltage difference. It is measured in farads. 1 farad is 1 coulomb per 1 volt. All right, it's completely dependent on the geometry of the material and the space packing it. So for a parallel plate capacitor, for a cylindrical capacitor, spherical capacitor, the capacitance will change. A lot of people think if I increase the charge, capacitance will increase. Wrong. If I increase the charge, voltage will increase, not capacitance, because capacitance only depends on the geometry, the shape, size, etc. So for a parallel plate capacitor, it is epsilon naught A by D. But if you add some dielectric medium, then that K value will also come over there. K being the dielectric constant of the medium between the plates of the capacitor. A is the area of the plates and D is the distance between the plates. When the capacitors are in series, use the formula like in resistors in parallel. So 1 by C1, 1 by C2, 1 by C3 is 1 by C. But when capacitors are in parallel, use the formula for resistors in series, the simple addition. C1 plus C2 plus C3 is the total capacitance. The energy stored in a capacitor of capacitance C with charge Q and voltage is given by multiple formulas, half CV square, or you can use half Q square by C or half QV. Just like for power, you can use V square by R or I squared R, or for centripetal acceleration, V square by R or omega square R. Same way, multiple ways of writing it, because we know Q is equal to CV. So same way, half QV, half CV square, half Q square by C are the electrical potential energy stored inside that particular capacitor. There is energy density also. Electrical energy density is how much energy is stored per unit volume, which is half epsilon naught E square. Half epsilon naught E square. Okay, half permittivity into the field square between the plates gives me energy stored per unit volume. Keep that in mind. Okay. Next, the potential difference between the conductor radius and outside spherical. This is okay only, nothing great. Medium between filled with an insulating substance. Okay. This is basically the concept of polarization and dielectrics. So whenever you add a dielectric medium between the space inside a capacitor, then when you connect it to a battery, then there is a voltage created. So there is a field which is going to pass. So the dielectric medium, there will be polarized molecules which will oppose the external field, thereby reducing the electric field within the dielectric medium, because the polarized material will oppose the outside field. So as a result, the net field tries to reduce, but my battery connected is still the same. So in order to maintain the same voltage between the plates, my electric field should be compensated and it should increase. because the medium is trying to decrease the field. So to compensate that, what happens? More charge gets stored on the plates of the capacitor. Thereby, even though the field reduces, it comes back to the original field. So the field is only increased so many times because more charge gets stored. So even if it tries to decrease, it compensates it. So that's how more charge gets stored and the capacitance indirectly increases. Think of it like this, that I know, you know, I'm going to solve two questions wrong, in the examination. So I solve more questions, so more correct questions rather, so as to compensate for those two incorrect questions which I'm going to solve. So that is the whole purpose of this. So when I'm solving more questions is analogous to saying I'm storing more charge on that capacitor. Okay. All right. Electrostatic shielding. Electrostatic shielding is another important concept. Questions can come on that. So imagine there is a cavity with no charge inside a cavity, then no matter what happens outside the conductor, even if there is intense field outside, the cavity inside is shielded, and from whatever is outside the cavity, this is called electrostatic shielding. So imagine you have your phone or something. Now this is a remote, but chumma, just assume my remote is my phone. Okay. So if you have a phone and you want to avoid someone, okay, you had a breakup, you don't want to talk to your friend, one option is you can put it on switch off, but then the person will get to know you're switched off. So what you can do is you can take a box, metallic box, and keep that phone inside of it. Then it feels that the phone is unreachable. So it gives that false perception that the phone is unreachable. You can try it out. Okay, practically also you should take a proper conducting copper vessel or something, properly enclose it. That is electrostatic shielding. So whenever you have a cavity inside a conductor, then the electric field from outside cannot pass through the conductor, because the conductor always blocks the electric fields from outside or even from inside. So there is no way of knowing whatever is happening outside the cavity, outside the conductor. All right. It's also called as Faraday's cage. Yeah. Next, let's do questions. I'm just going to directly do questions, guys. I wanted to just complete this theory part. My throat is not helping, and I really want to save my throat for tomorrow also, and even on the day of the examination. So let's just do the questions part now. All right. Ready, guys? Everyone? Paka? Okay, let's do this. A solid sphere of radius r has uniform volume charge density. The electric potential at points r less than r. Electric potential at points. A solid sphere of radius r has uniform volume charge density. Due to the charge inside of the sphere r only, due to the entire charge of the sphere, due to the charge in the spherical uh, inner and outer radar r and r only, due to the charge in the spherical shell of inner and outer nono, independent of r. So first understand the question, what it means. So here they are mentioning that hmm, you have a solid sphere of radius r, and there is charge filled inside of it completely. Okay, it is completely filled with charge. Everywhere it is filled with the charge. So now you are at, let's say, some distance over here. This is small r from it, and the question is, at this distance of small r, what do you think is the potential going to be, because of, due to inner outer, what do you think? The answer is, it's because of literally everything. So whatever is there inside will also give electric potential at that particular point. Not just that, even these charges over here, even these charges over here will give rise to electric potential. It's not electric field. If the question was electric field, then the answer will be only because of the inside charges. Outside charges will not matter. But electric potential, it's because of inside and outside both. So due to the entire charge, option B is the right answer. Yeah. All the chapters of part 1, the 177 are okay, all the chapters. Yeah. All right. All right. Only problems alone. Okay, let's go. Question number 2. Potential gradient at which the dielectric of a condenser just gets punctured is called. So the potential gradient at which, potential gradient means dV by dr. Now what is dV by dr? Technically, magnitude wise, it is electric field. So the electric field at which the dielectric gets punctured means you are causing a breakdown. You're causing a breakdown. What is it called? It is called as the dielectric. Yes. Constant? No. Dielectric resistance, dielectric number, it is called as the dielectric strength of that medium. Yes. No, it is not A, guys. Dielectric constant is completely different. It is the K value. How many times will the field reduce? The maximum value of this, the max value of this, that is called the dielectric strength. K is just a material property, yeah, but it tells me how many times will my field reduce by, but not the maximum limit of it. Dielectric strength is completely different. It is having a unit of Newton per coulomb. Dielectric constant is unitless. Reminding you again, it is unitless. Okay, all right, perfecto. Shall we go ahead to the next one on your screen? The electrostatic potential on the surface of a charge conducting sphere is 100 volts. So two statements are made in this regard. Statement 1, okay, at any point inside the sphere electric intensity is 0. At any point inside the sphere the electric potential is 100 volts. Which of the following is correct? Okay, so imagine this sphere. The electrostatic potential on the surface of a charge conducting sphere is 100 volts. So because it is a conductor, all the points should be having the same potential. So statement number 2 is absolutely correct. At any point inside the sphere, the potential is 100 volts and electric field inside of this will always be 0. Yes, electric field inside will always be 0. So electric intensity is 0. So statement 1 is correct. So both are correct. Both S1 and S2 is also correct. S1 is true, S2 is also true, but they are just independent of each other? No, they are the in fact causes of each other, because electric field is 0. Electric field is dV by dr. Because this is 0, that means dV by dr is 0. Therefore, voltage should be constant. That is the reason of it. So option C is the right answer. Yeah, very good. Perfect. Amazing, amazing, amazing. Many of you got it rightly. Very good, guys. Moving on. The electric potential inside a conducting sphere. Electric potential inside a conducting sphere increases, decreases, remains constant from, okay, 0 at every point. The electric potential whenever you are inside a conductor will always be constant everywhere. So I just explained that. So it remains constant right from the center to the surface. Option C. Yeah, perfect. Let's go next one. A charge is projected into a non-uniform field. Work done when it moves by distance y is, it's moving in a non-uniform, sorry, it's moving into a uniform electric field, my bad. Then the work done when it moves a distance y is how much? Well, work is force multiplied by displacement. Force is charge into the field. Displacement is y. So QEY. That's it. Option number A. That's all. QEY. Option A. Very good. IN me camp 1, 2, 3, 4, 5. Awesome. 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 Subjective is also going to come, man. See, subjective is coming. Why does electric field inside a dielectric decrease when it is placed inside external field? So you have to explain it properly. Okay. So now this is 1 mark. If it is 2 marks or 3 marks, more statements will come. So why does the electric field inside a dielectric field decrease when it is placed? So first of all, if you have a dielectric medium and there is some external field from outside, then what happens? The internal material gets polarized. So positive, negative, positive, negative, positive, negative, positive, negative. These words are important. Polarized. Polarization happens. Mention that. Because of these polarizations, you will see electric dipoles will oppose the external field. So there will be opposing fields due to the polarized molecules, which are then going to reduce the net electric field. So this opposition comes because of the polarization internally. So these words and diagrams are important. So electric field inside the dielectric decreases due to the polarization, and it creates internal electric field opposite to the external field inside the dielectric, due to which the electric field gets reduced. All right, next one. What is the work done in moving a 2 microcoulomb charge from corner A to corner B of square ABCD, where 10 microcoulomb charge exists at the center of the square. Okay, let's have a look. So there is a 10 microcoulomb charge at the center of the square, and you have to move another charge from corner A to corner B. So let's say this is corner A to corner B, and you want to take this charge of 2 microcoulomb and you want to move it over here. Guys, think logically and answer the question. Don't you see that potential of A is equal to potential of B, since distance of A is equal to distance of B? A point and B point are at same distance from the central charge. So potentials are same. So the potential difference between A and B is 0. So the energy difference between A and B is 0. So the work done to take it from A to B is also going to be 0. Answer is 0. Perfect. Awesome. 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 Very nice. Very nice. Moving on. Next question. Show mathematically that the point potential on the equatorial line of an electric dipole is 0. So when you talk about electric dipole and we are talking about the equatorial point means this one. This is the equatorial line. This is equator. So what happens, no matter where you go, you will always be equidistant from both the charges. You will always be equidistant from both the charges. So if this is R, this is also R. So the potential, the net potential will be potential due to positive and potential due to negative. Due to the positive charge, it will be KQ divided by R. Due to the negative charge, it will be K negative Q divided by R. So the sum will be 0. So always the potential will be 0. That's all. So this is what you are going to mention. Okay, cool. Next one. A parallel plate capacitor between the plates has a capacitance of 8 picofarad. Pico is 10 to the power negative 12. What will be the capacitance if the distance between the plates is reduced by half and the space is then filled with a substance of dielectric constant 6? So we know capacitance is epsilon naught A by D. So what will be my new capacitance? Let's have a look. It will be epsilon naught. If the distance between the plates is reduced by half and the space between them is filled with dielectric constant 6. So epsilon naught A multiplied by 6, distance is reduced by half. So 2 goes on the top, 2 6 are 12. So 12 epsilon naught A divided by D. That means 12 times the old capacitance. So 12 multiplied by that old capacitance, 8 picofarad, guys. Okay, so that is going to be 96 picofarad. That's the answer. Very good. 12 times. Yeah, simple, easy peasy, lemon squeezy. Very good, very good, very good, very good, very good. Next question on your screen. Prove that the energy stored in a capacitor is half CV square. Yes, this is a proof. This kind of question can also come. So how do you do this? So you show a diagram basically and show a battery like this, show the capacitance, show the voltage, or let's say like this, and then you show at some instant the charge stored is Q, and now you are adding dq charge. You are adding dq charge into the capacitor. So because of this, the small work done by the battery goes into the small change in the energy in the capacitor. Small change in energy in the capacitor. The work done by the battery is always the charge which flows in that battery multiplied by the potential difference. So the charge which flows is dq, potential difference is v, but we all know voltage on the capacitor is q divided by c, because q is cv. So v is q divided by c, that is du. So therefore u will be integral of du, which is integral of q dq divided by c, which is 1 by c, and integral of q dq from 0 to the final charge stored in it. So that will give you half q square divided by c. That's the definition, sorry, for formula derivation for energy stored inside a capacitor. Okay, just in case you get that kind of question, you might get. So let's go to current electricity related questions. So the theory points, I will keep it as slides. Later on, you can go through it. So all these things, I'll give it to you. Important points to revise before the examination. All right. Here is the first question, guys. Come on. Deleted, not deleted, you never know, man. Just if they ask, just keep it in mind, okay? It's not a big deal. You never know. CBSE these days acts very weird at times. Okay? Paka? Not a big deal. In the absence of an electric field, the mean velocity of free electrons in a conductor at absolute temperature T. In absence of electric field, the mean velocity, guys. See, electrons will move randomly. Electrons will move randomly. So, average displacement, because it moves randomly like this, after some time their average displacement will be zero. So average velocity is also zero. They did not ask speed, they asked velocity. It is a vector quantity. Displacement is zero because it comes back to its same place after a long time. So hence the answer is option A, guys. Lot of kids make mistakes here. They write independent of T, proportional to T and all of that. The answer is not just independent, rather it is perfectly zero. Although you can say independent of temperature also, because even if you change the temperature, the answer will still remain zero. Like that, technically even independent of B is also right, but the more right answer is absolutely zero. Okay. Although it can be debatable that both options are right, so it can put CBSE people in a soup then. Okay, a cell of internal resistance is connected to a external resistance of NR. Then the ratio of the terminal voltage to the EMF of the cell. Terminal voltage versus the EMF. So draw the diagram just for your reference sake. This is E, this is R. External resistance is NR. So what will be the current in the circuit? It will be EMF by total resistance, which is R plus NR, which is E divided by R, N plus 1. Now the question is the terminal voltage to EMF. Terminal voltage by EMF. Terminal voltage, this voltage is basically current into external resistance, which is NR, divided by EMF. Now the current we already know is E divided by R, N plus 1. Then here we have NR, and what else is there? NR is there, and this E is there. Okay, so E got cancelled, RR got cancelled. So N divided by N plus 1 should be the answer. N divided by N plus 1 is option C. There you go. So the voltage across the battery terminals is also the voltage across this, and that voltage is current into resistance. Resistance is NR. Simple. So substituting, you'll get the answer. Okay, J Advance 2028. I'm not going to win but dominate. Can you give me any tips? Tejasvi, I really hope my blessings are with you, and I really hope you keep following me, my lectures, and in the near term. All right, stay tuned, man. God bless you. 2028 Warrior is right over here, right now in 10th standard. All the best for your board exams, do. A metal rod of some length and rectangular cross section is connected to a battery. The resistance will be maximum across which cross section? This is a good question, guys. Many students make some mistakes over here. So the resistance is given by resistivity into length divided by area. So if the length is more and the area is less, then you will get maximum resistance. So if you think about the dimensions of that particular cuboid, you will see one is 1 centimeter, other one is 0.5 centimeter, and the other one is 10 centimeter. So I want the length to be maximum and area to be minimum. So I think then it makes sense that the current should enter like this, so that this will be the cross section. This will be that cross section across which it goes. It should come out from here. So length is maximum and area is as minimal as possible. So resistance is maximum. So maximum when the battery is connected across 1 centimeter face. So I think option A is the right answer. Just check this out. Option A, guys. Not C. Maximum when it is 10 cross half. No, 10 cross half will not be right, man. How will it be right? 10 cross half. So when it is 10 cross half, it is not the least area. Least area is 1 into 0.5 centimeter. Okay. Length should be maximum. Area should be minimum. Is that okay? Yeah. Yes, I'm the weakened. Yes, that is absolutely correct, man. Moving on to the next one. Resistance of an ammeter is 13. Up to 100 amps it can measure. If you want to measure up to 750 amperes, how much shunt should be added? So what to do in such situations? Visualize your galvanometer. Okay, it is of how many ohms? 13 ohms, and it can measure only up to how many amperes? 100 amperes. 100 amperes. So what you are doing now, you are connecting a shunt over here like this. Now I do not know how much the shunt is, but I am going to send in over here 750 amperes. So out of 750, 100 will go here. The remaining 650 amperes will go through this, so that it is safe and protected. So in such a case, what will happen is the voltage across both of them will be the same because they are in parallel. Voltage in parallel is basically the same. So the voltage across the shunt resistance will be I into R. So 650 multiplied by the shunt. The voltage across the original ammeter, current into resistance. So 100 multiplied by 13. Now 13 goes with 65 5 times. So 5 into RS, but 10 was there and this 100 is there. So RS will be 100 by 50, which is 2 ohms. So 2 ohms is the right answer. How many of you got the correct one? Yes, Karthik Kumar. Awesome. Yes, so 10 centimeters is the maximum length. Yes, connected across. Yeah, correct, man. 10 centimeters is the maximum length. So which phase are you connecting the wire? The wire is connected to 0.5 into 1. 1 into zero point 0.5 phase. Maximum when it is connected across 1 into zero point 0.5 phases on both sides. So the length of that wire is maximum. Correct only. Okay. All right, I'll try to start the lecture tomorrow early only. No worries. If the temperature of a good conductor decreases, how does the relaxation time of the electrons in the conductor change? Try to recollect any formula which you know. Yeah. If the temperature of a good conductor decreases, how does the relaxation time get affected by it? Recollect resistivity or conductivity formula, guys. Yeah, it is nothing but M by, what is the formula, guys? N E square, I think, and relaxation time and stuff like that. Just check this out. So what will happen if the temperature of that good conductor decreases? How does the relaxation time will change? So what happens is, when the temperature reduces, the thermal energy will reduce. Because the thermal energy will reduce, you will see that the will resistance will decrease. Yes, for a conductor, when the temperature reduces, the resistance also reduces. So resistivity also reduces. So relaxation time will increase. So they will collide less frequently. Between one collision to the next collision, it will collide after a longer time. Yeah, so answer is increases. Perfect. Moving on to the next one. If potential difference is applied across a conductor is increased to 2 volts, how will the drift velocity change? Just 1 second, guys. Let me drink some water. Meanwhile, answer this. Hmm. Potential difference is increased. How will the drift velocity change? Yeah. Doubles, twice, increase. Okay. What's the formula for drift velocity? Well, drift velocity, if you remember, is nothing but E, and then you have that electric field, and then divided by mass, and then the relaxation time. All right. Over here, that's one formula which you have. Now, if you increase the voltage, if you increase the voltage, what will exactly happen? If you increase the voltage, if you voltage, voltage is doubled, then the current will also be doubled. Current is doubled, so you can say that even the drift velocity, because relaxation time, all these things will not change, so even the drift velocity will also be doubled only. In fact, we don't even need this formula, we can directly use this formula, guys. Current is equal to NVDR. So current is directly related to the drift velocity. If current doubles, drift velocity will also become double, 2 times. Yeah, you can say that. Okay, perfecto, man. Awesome. Moving on to the next question. Two bulbs are there, A and B. They are marked 220 volts, 40 watts, 220 volts, 60 watts. Which has higher resistance? So whenever you have bulb related questions, they can be converted into a resistance. How? So the power and the voltage is given. So what you can do, power is nothing but V square divided by R. So the resistance that you want, because power is V square divided by R. So the resistance that you want is V square divided by P. As you can notice, both of them have same voltage but different power rating. For same voltage, different power rating, R is inversely proportional to P. So the one which has higher power has lower resistance. So which has higher resistance? So obviously then the one which has higher resistance will have lower power. So higher resistance will be there for lower power. Out of 40 and 60, 40 watts. So 40 watts is the answer. Okay, because resistance is inversely related to the power for the same voltage. Yes, bulb labeled A. So bulb labeled A will be the right answer. Very good. Harnish, Karthik, very good. I'm the Woods. Awesome, Shakti. Awesome, awesome. Keep answering, guys, like this only. Proud of all of you. Moving on to the next one. What happens to the resistance of the wire when its length is increased to double its original length? What happens to the resistance of the wire when the length increases to double its original length? So you are stretching the wire. So a lot of people think resistance is rho L by A and you're doubling the length. So, the resistance will also become double, but that's not right. See, when you are pulling it, area will also change. So it is actually rho L. Area of cross section is volume divided by length. Think about it. If you take the wire, this is the area of cross section, this is the length, the volume is area into length. So area will be volume divided by length. So technically speaking, this will become rho by volume into L square. This volume is constant. So you can see resistance is proportional to length square, which means if the length doubles, the resistance will become 4 times. So the answer is not double. A lot of kids make this mistake. It is 4 times. Got it, guys? Be very, very careful, huh? Such questions. All right. Let's move to moving charges and magnetism chapter related questions, guys, on your screen now. Okay. The theory part slides, I will give it to you as printed material. In the description box, there will be a PDF available. A current carrying loop is placed in a uniform magnetic field. The torque acting on it does not depend on shape, area, value, magnetic field. So the torque is M into B into sine theta. Okay, magnetic moment is number of turns into current into area into and then B into sine theta. Shape of the loop, yes, it doesn't depend. Area, it depends. Value of the current, it depends. Magnetic field, it depends. So it does not depend. So the question is, it does not depend on. So it does not depend on the shape of the loop. Option A. Very good. Next one. A beam of electrons is moving with some velocity inside a region having simultaneous perpendicular electric and magnetic fields of 20 volt per meter and 0.5 Tesla at right angles to the direction of the motion of the electrons, and the velocity must be. So if the velocity is constant, then it is the concept of crossed fields, and whenever such crossed fields come, velocity is E by B. It's electric field by magnetic field. So 20 divided by 0.5, guys. So that is going to be 40. So answer is 40 meters per second. So what happens in such cases is, whatever force is there, by electric field and force by magnetic field, they end up cancelling out each other. So there is no net force. And because there is no net force, therefore velocity is going to be constant. So that is the concept of that. And it happens that V becomes E by B. Okay, that is the standard formula which you should remember. Next, let's do this. Consider the statements and select true and false. Force on a charged particle will be zero if it is at rest. It depends whether we are talking about electric and magnetic fields. Force on a charged particle will be zero. If it is at rest, not necessary. Direction of the force on a moving charged particle is given by Fleming's left-hand rule. A charged particle enters a region of uniform magnetic field at an angle of 45 degrees to the magnetic lines of force. The path of the particle is a circle. There is no change in the kinetic energy of the charged particle moving in a magnetic field, although magnetic force is acting on it. So if I go from behind, guys, you can already see there is no change in the kinetic energy when it goes through a magnetic field, because magnetic force is always perpendicular. It can only change direction, but not the speed. So yes, fourth option is absolutely correct. So that is true. So you can see true is there here, here, and here. Next, a charged particle enters a region of field at 45 degrees. It will go in a helical path. It will not be a circle. So it should be false. So as you can see, this is also false. This is also false. Can you see that? Yeah. So either it is A or C. Your D option got eliminated. B option also got eliminated. Then if you look at, let's say, even the first statement, force on a charged particle will be zero if it is at rest. Well, magnetic force will be zero, but electric force can be there. So they have not mentioned whether it is electric force or magnetic force. Electric force will be maybe there, but magnetic force will be zero. So force will be zero is wrong. It is false, guys. So you can see this option is absolutely the right one. Option number A. And yes, a charged particle, direction of the force is given by Fleming's right hand rule. Yes. So guys, automatically all these things can be judged. Is that clear, everyone? Pakka. Let's move on to the next question. A moving coil galvanometer, number of turns, coil area, it carries a current, magnetic field is radial, the torque acting on the coil is magnetic moment into B into sine of 90 for a moving coil galvanometer. Magnetic moment is number of turns into the current into the area, so into B, sine 90 is 1. So NIAB is the answer. NIAB, which is option number D. Yeah, perfecto. All right. All right. The best paper to write as a mock test is number one, the previous year. Pick out the most difficult shift. If we are 2 days before, so that's fine. But at the last moment, pick out the easiest shift and obviously the sample paper. These are the only papers which are the best mock tests which you should probably look at. Okay. The most difficult if you are slightly more confident, the easiest set if you are not so confident, and sample paper is anyways you have to look at it. Okay, but that can be secondary. All right, moving on. Next question. State two properties of the material of the wire used for superposition of the coil in the moving coil galvanometer. What are the two properties of the material of the wire which are used for suspension of the coil? Yes, come on, think about it. That material of that coil, what should it be, guys? Yeah, what should be the material of that particular coil so that it functions like a galvanometer? Come on, let me know. Thank you so much, Harinesh. Yeah, in the chat box. First of all, that coil should be what? Iron core magnetic. Yes, the material of the wire. Oh, guys, wait a minute. We are talking about the material of the wire used for the coil, not the magnet. No, it's not magnetic material. That is not the right answer. We are talking about the coil which is suspended between the magnets. Between the magnets. So north and south. So we are talking about that coil which is suspended. Be careful. Be careful. Yes, it should be paramagnetic, wrong. It should twist easily, yes. And it should be springy. Okay, it should be springy. Okay. So first of all, it should have very less resistance, meaning good conductor. It should be a very good conductor. It should be a very good conductor. Okay. It should be able to spin very easily. Yeah, meaning it should not have more inertia. Twist. It should twist easily with less torque. With less torque. Okay, because it's a sensitive device, so it should twist easily when current passes through that particular coil. Correct. Yeah. Radial field is not the right answer, man. We are not talking about what magnet should be used, what are the properties of the magnet to be used. So that is why be careful what is the question, or else you will give a wrong answer, you will get 0 marks for it. Okay, be very, very careful. Yeah. Also, you can say that this particular material should be, it's a coil, right? So whenever you have a coil and basically it will be twisting again and again. Imagine the needle moves this side, that side, this side, this side, that side, that side. So many times you'll use it. What will happen when you twist it so many times? It might break. Have you seen your compass box or any pen or anything? You keep doing this. You're attending one lecture, boring lecture, tuck, 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 you keep doing, it breaks. So that should not happen. So it should be not brittle. So it should not be brittle. It should not be brittle. Okay, that is another important characteristic. Yeah. Okay. Not high tensile strength. Soft iron core is not right. Yeah. Low torsional constant, yes. It should twist easily with less torque, means low torsional constant. Why less resistance? Because it's a coil, and if it has high resistance, then first of all, it will block so much of current, number one. Plus, number two, guys, it's a current sensitive device, and the galvanometer coils are usually of very, very low resistance. So if you have a very resistive wire, then the resistance of the galvanometer will become very high. Okay, so please keep that in mind. It should be conducting in nature. Suspension means it is hung. So that coil is hanging between 2 points, or there is an axis, and when magnetic field is applied and current passes, there is a torque and the coil will twist. So that coil will twist when current passes. So it is hung between 2 points, and there is a spring over there. That spring brings it back. So as the coil twists, that wire will also twist. So if you do it more times, it will break. So it should not be brittle. Okay, these are the important things. Zero wire resistance is not possible practically. We are talking about practicality, not theoretically. Practically, zero resistance is not possible. Theoretically, yes. Okay, perfect. Awesome. Moving on to the next question coming up on your screen. Well, if you want moving coil galvanometer, guys, you can always go over here and you can search for my lectures on moving coil galvanometer. In fact, I'll tell you, if you go to the homepage, you don't even have to search. Past live streams. Bro, CBSE board. Can you see the CBSE 2025 physics full playlist is there? Moving charges, magnetism, EM waves. Yeah. So if you open up this lecture, it's a 8-hour class. Okay. So please check that out. This is a 3-hour class. This is a 10-hour class, and all of that. Proper explanations. So just go through this particular lecture. I've explained every single concept to all of you. Okay. So you can go through this entire lecture. This is NCRT line by line. There is also a lecture for most important derivations. This is also important, but you never know. Sometimes they do not ask derivations. Sometimes they ask derivations. Last year they asked some derivations, but again, year after year they change. Okay. Yes, I know. Nidarshan, definitely, man. Very soon, very soon, very soon. Okay. What will be the path of a charged particle moving along the direction of a uniform magnetic field? Yeah. What is the path of a uniform charged magnetic field? Yes, along the direction. So if this is the magnetic field and the charged particle is thrown over here, then V cross B will be 0, because sine of 0 will be 0. So the force will be 0. So velocity will be constant. meaning the path taken by it, will be a straight line. Okay, it will be just a straight line. Yes. Yeah. No deflection, not circular, not helical. Be careful, man. Yeah, it moves undeviated. Be careful. Read the question, guys. Such simple questions, 1 mark questions. You cannot go wrong about it, man. Please be careful. Okay. Moving on to the next one. A steady current flows in the network. What will be the magnetic field? I think it did not get printed. Let's go to the answer slide. Okay, I think this was the network. What is the magnetic field at the center of the network? That means over here. So what happens? This wire and this wire will not give any magnetic field here. This wire, if you see, the magnetic field will be inwards. This wire will also be inwards. This wire, if you notice, the magnetic field will be outwards towards you. This wire will also be outwards towards you. So PQR and PSR, they will give magnetic fields of equal amounts, but one is inside, one is outside. So they will end up cancelling out each other. So there will be no net magnetic field only. So the answer is perfectly 0. Okay, that's the logic behind it. In fact, all these questions, it's also there in JEE many times. They will give this structure, sometimes hexagon, sometimes pentagon, sometimes a circle. Current enters and exits from some other point. What is the magnetic field at the center? Always the answer is 0. Forget quadrilateral, even if it was a triangle, even if it was a circle, even if it was a hexagon, the answer is always 0. I'm not saying the current is going in a circular manner. No, the current should enter at a point and exit at some other point. Okay, it should get distributed and come back and then exit. Only then the answer is 0. Keep that in mind. Alpha particle proton are moving in the plane of the paper where there is uniform magnetic field directed normal to the plane of the paper. If two particles have equal linear momentum, what is the ratio of the radii of their trajectories in the field? So here you will need the formula for the radius which is taken. All right. So what is the ratio of the radius of the trajectory? Radius is mv divided by qb. Mass into velocity is momentum and divided by charge into field. Momentum is same. If the two particles have momentum same field, so the radius is indirectly proportional to the charge. So radius of, what is this, alpha and a proton. Alpha by radius of proton will be charge of proton divided by charge of alpha. Proton has plus E charge, alpha has plus 2E charge. So it will be 1:2 ratio. So the answer is 1:2. Very simple. Directly, very good. Not 2:1. If you write 2:1, you will not get marks. At least 1 mark will be lost. They will cut marks. Be careful. Okay, cool. Let's go to the next one. On your screen, we are talking about the chapter of magnetism and matter, magnetic materials, magnetism. So all the theory slides are right over here. Let's directly go to the questions over here. How does the intensity of the magnetization of a paramagnetic material vary with increasing applied magnetic field? Para, dia, ferro. Dia is the worst. Go die, man. Like opposite. Para is like, okay, little bit, it loves the magnetic field. Ferro, Ferrero Rocher, chocolate, you love the Ferrero Rocher chocolate. So ferromagnetic material loves the magnetic field. Think of it like that. Dia means go die. Ferrero Rocher. It's like, okay. So paramagnetic material loves the magnetic field. So the magnetization will obviously increase when applied magnetic field also increases. So this is the paramagnetic material. If my external magnetic field increases, then you will see the internal magnetization, the magnetization also increases. So the magnetization also increases in the same direction. It supports it, it becomes magnetized. It is not strongly attracted, it is weakly attracted. Paramagnetic materials are weakly attracted. So it increases, not so much, but it increases. If it was ferro, it increases like crazy. Okay, ferro loves that particular material. All right. A bar magnet, magnetic moment is aligned parallel to the direction of a uniform field. What is the work done to turn the magnet so that it aligns its magnetic moment opposite to the field, normal to the field? A bar magnetic is aligned parallel to the direction. So bar magnet is aligned parallel to the direction of the magnetic field. So in such a case, the initial magnetic energy will be minus mb cos theta. Theta is 0, cos 0 is 1, so minus mb. That is the initial magnetic energy. Now let's go to the first point, opposite to the direction. So magnetic moment is opposite to the field. So in such a case, the magnetic energy is minus mb cos 180. Cos 180 is minus 1. So minus minus becomes positive, so it will become mb. So the work done will be final energy minus initial energy. Final energy is mb, initial energy is minus mb. So hence the answer will be nothing but 2 times of mb. So the work done is 2 mb. Next, let's go to this question, normal to the field. So my magnetic moment is perpendicular to the field. So my final magnetic energy will be minus mb cos 90 degrees. Cos 90 is 0. So the work done will be final minus initial energy. Final is 0. Initial is minus mb. So hence minus minus will become plus and it will become plus mb. So the work done in the second scenario will be plus mb. That is the answer. All right, perfect. Let's go to the next question. A short magnetic, just read the question, 1 second. Short bar magnetic magnet of magnetic moment so much placed with the axis 60 degrees to the field, it experiences torque. Calculate the strength and what orientation corresponds to the equilibrium position. Hmm. 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 Let's do this. So magnetic moment is given, angle is given, torque is given, and we know torque is mb sine theta. Sine theta. Torque is how much? 0.063. Magnetic moment is how much? 0.9. B is not given. Theta is how much? Sine 60. So B will be nothing but 0.063 divided by 0.9, and sine 60 is the root 3 divided by 2. That's it. So calculate this, guys. 9 goes with 63 how many times? 7 times. Yeah, so if you shift the decimal, this will become 0.63. So 0.63 divided by 9 is 0.07. So 0.07 multiplied by 2 divided by root 3, which is 1.732. Yeah, so approximately you can get the answer, guys. Just check it out. If it comes out as 0.081 Tesla, 0.081 Tesla, that should be the answer. Just check this out. Okay, perfect. Somebody wrote the answer already. Very good. Last one, what orientation corresponds to equilibrium position of the magnet? The magnet is at equilibrium if it makes an angle of 0 degrees or even 180 degrees. Both answers are right. A lot of students miss 180 degrees. In both the cases, the net torque is 0. So both are corresponding to the equilibrium of the magnet. Yeah, everyone, both 0 degrees and also 180 degrees. Cool, pakka. Let's go, guys. Next one. Yeah, electromagnetic induction chapter. Let's have a look at the questions on your screen now. Electromagnetic induction. Yeah, EMI. A coil of some area is placed at right angles to the magnetic field. The EMF is this much induced in the coil. When the field reduces by 20% in so much second, find the magnetic field. Okay, so coil, magnetic field, it reduces. Okay, so what is the B value? Okay, voltage is also given. Now the EMF induced is given by rate of change of flux del phi by del t. So it is nothing but final magnetic field into area minus initial field into area. Okay, whichever is bigger I'm taking. I'm just forgetting the sign over here. I'm just interested more in the magnitude of it upon the time interval. So area anyways is common, delta t is there, and here just the difference of the magnetic fields. Okay, so the EMF value is already mentioned, which is 0.32 volts. area, somewhere it is given, time is also given 0.5. Now magnetic field. So final magnetic field is reduced to 20% of its initial value. So 20% means 0.2 of B, and originally let's say it was B. So this will become 4 by 0.5 is nothing but 8. 0.5 on the top will become 2, 4 2s are 8. This will become just 0.8 times of B. Okay, so 0.8 into 8, 8 is a 64, so this will become 6.4 times of B is 3.2 divided by 10, I can say. Then I can write B as 3.2 by 6.4, and this is 1 by 10 as it is. This is nothing but half, which is 0.5. So 0.5 divided by 10, which is 0.05. So 0.05 is option B. Option B, guys. Yes, very good. Very good. Yes, totally, Sidwaiti. One is stable, one is unstable. If you're talking about the previous one, I mean this one, this is the stable equilibrium, this is unstable equilibrium. In the question, they didn't mention whether it was stable or unstable. If they just used equilibrium, then both are equilibrium. But if they mention stable, then 0 degrees, unstable, then 180 degrees. Okay, so you can leave the answer open-ended because both are actually equilibriums. Let's go. In a coil of some resistance, induced current by changing the flux shown as a function of time, the magnitude of the change in flux through the coil in Weber is how much? Okay. So, as you can see, the current versus time graph is shown, and the question is, what is the magnitude of the change of the flux? All right, so let's think. EMF is change of flux by time, that is Faraday's law. Change of flux is asked. So, change of flux is EMF multiplied by the time. Voltage is current into resistance, so current multiplied by resistance multiplied by time. Current is charge divided by the time, and resistance into the time as it is. Delta T will cancel, so charge multiplied by resistance. Now from this graph, I know that charge is nothing but area under current versus time graph, so into resistance. So that's it, because charge flowing is the area under this graph. The area under this graph is the charge. So half into the base into the height. So 4 by 2 is 2. 2 into 0.1 is 0.2. So 0.2 multiplied by resistance, which is 10. So it will be basically 2 Webers. So 2 Webers will be the answer, which is option B, of course. It's a very good question. Okay. It's a very good question. No, it is not 4, man. Area of that figure is half into base into height. So 2 into 0.2 is 0.2. Resistance is 10. Yeah. So the answer is 2 Webers. Why are you saying 4, man? No, it is not 4. Be careful. Shakti, Sanjay. How to do the question in EMI to construct a graph in induction? Not really sure which question you are talking about. Can you be very specific? JKIB 2624. Peter World, I'll be making a separate video on how to join the Eklavya batch for JEE Advanced very soon. Just give me some time. I'll make that video. Okay. But is this clear, guys? How to do this? See, here what did we did? We multiplied delta T over here. So it went this side. EMF is I into R. Current is charge per unit time. So we forgot that delta T because it got cancelled. Charge flowing in a graphical way is the area under current versus time. So we found the area. That's it. A lot of people, what they do is they forget these steps. They just use this formula and they use current as 4, resistance as 10, delta T as 0.1. That is wrong. How can you take current as the initial current? Why not any random current? So this is not the right way of doing it. Putting current as 4, time as 0.1 and resistance as 10, that is wrong, guys. Be careful. Okay. Here, understand, this is the average current. This is not the initial current. So the average current is the total charge by total time, and the total time got cancelled, and the total charge is the area under current time graph. That is the conceptual mistake. Why many people write the answer as 4, because you have used this formula and not cancelled delta T. Okay, moving on to the next one. The total charge in a conducting loop when it is moved in a magnetic field depends on the rate of change of flux. initial flux, total change in flux, okay, there is no way of doing it apart from formulas. So delta phi by delta t, again the same logic, delta phi is E into delta t, EMF is current into resistance, so into delta t, current is charge by delta t into R into delta t will cancel, so charge into resistance is delta phi. Okay, now the question is the total charge induced, so Q will be delta phi by R. So the charge induced is depending on what? Resistance and the change in flux. The rate of change of flux, the total change in magnetic flux. Answer is C. So delta phi, not delta phi by delta t. See, be careful. Rate of change of flux is delta phi by delta t. That EMF will be dependent, not the charge. Charge is only dependent on how much it changed. How quickly it changed doesn't affect it. Okay. How to find resistance? Resistance was already given, no man. It is already given. Why do you have to find resistance? It is already given. Ekalavya, man, Darshini, always Ekalavya. Yeah, if you're talking about the end moment, Eklavya is not there for 2-year program. Eklavya is always like a 6-month, 7-month, 8-month program, because initially we give equal importance to all the students. Basically, every student is the same. But as we near the end, then only the student identifies their strengths, their weaknesses. We also can, decide what should be the student trained for, whether mains or advanced towards the end. So accordingly, we train the students towards the near end. Okay, so 6 months, 8 months, 9 months, that's how the program works. So the Eklavya started back in the month of October, if I'm not wrong, and now the Eklavya entry point is there in month of February, so you can join it accordingly then. So will it be dependent on the resistance? Yes, it will be definitely dependent on the resistance, but in the options, resistance is not there. That's why I will not worry about that. Okay, but if there was an option, it also depends on the resistance, I'll mark that. Okay, but yes, it only depends on the resistance and the actual change in flux, not how quickly the flux changed. A result of the change in the magnetic flux to a loop EMF volt is induced. The work done in taking a charge once along the loop. You take this charge Q and you have taken it like this along this particular loop. So what will the work done be? Work done will be how much charge you took multiplied by the potential difference in that particular loop. So the charge taken is Q. The potential difference is nothing but the induced, EMF induced in that loop. So how much induced EMF was there? The induced EMF was V volts. So the answer is Q into V, which is obviously option A. Option A. It's a very good question. Many people think the answer is 0, but the answer is not 0, because a lot of people think of electrostatics chapter and they feel that if I bring the charge back to the same place, then the work done is 0. Yes, you're right. If you bring the charge back to the same place, the work done is always 0, but provided the electric field is coming from charges. Here, it is not because of charges, it is because of magnetic fields. So that's why you will see it is non-conservative in nature. And that's the reason why it is not 0. Okay, there is a big change over here. Cool. Let's go to the next question. There is a loop which is made of straight edges and has 6 corners. Okay, magnetic field is also present. The flux passing through the loop is how much? Okay, the only way to solve this is actually sit and draw the diagram. It's just going to take a little time, but with the diagram, things will become very obvious. This is x-axis, this is y-axis, and this is z-axis, let's say. Okay, let's draw the points. A 0, 0, 0. That means it is right over here. Okay, this is A point. B point is L 0, 0. So on the x-axis, this is this is your B point. Everything is L. Okay, then C point is L L 0. So right over B, it's over here. This is point C. D is 0 L 0, 0 L. Y coordinate is L. So this is your D point. And E is 0 L L. 0 L L. So this is where E point is. And F point is 0 0 L. That is right over here. That's it. and A, B, C, D. Okay, so let me just draw the loop. So this, then this, then this. As you can see, it feels like a bent sheet. Yeah, about that edge AD. It's like a bent sheet. And the magnetic field is passing along the x-axis and along the z-axis. So as you can see, there is a magnetic field which is in this direction along the y-axis and one along like this. So this magnetic field is B naught. This magnetic field is also B naught. So there are two reasons why the flux will come. One, due to this part, and second, due to this part, right? These are the only two places the flux will come. So in this part, the flux will be the field multiplied by the area. Area is L multiplied by L, so B naught L square. Next, the flux in this particular area, because the field is piercing through that sheet, you can visualize it, is field multiplied by area, which is L into L. So again, B naught L square. So talking about the total flux. Flux is a scalar quantity, no need of directions. So B naught L square plus B naught L square. So it will be 2 times of B naught L square. That's it. That's why I said drawing the diagram is very important in this question. B option. Yeah. All right. Fermi ferrocyanide. Oh my God. Arjun, I attended your lecture in October. Now I hope you remember me. Man, you come after 5 months. Yeah. Once again, sir, complicated method. Man, this is not a complicated method. Which one? This one, or are you saying, or this one? This though was a simple problem, but this one, drawing diagram is always easier. If you are thinking, sir, I will draw the area vector, take the dot product, that is more complex method. So drawing the diagram makes you realize that out of the two components of the magnetic field, which component actually contributes in the flux. Like for this part, it is the Z component. For this part, it is the I component. And from that, area into field gives you the flux, just add them and that is the answer. Okay, it's very straightforward only. Is that okay now? All right, perfect. Moving on to the next one. A metallic coil, stationary, non-field, uniform magnetic field, what is the induced EMF? Don't worry, man, tomorrow's lecture, I'll probably schedule it in the afternoon only. Yeah. Welcome, Kevin. Welcome, Kevin. Yeah. Sir, is it okay if I revise NCRT complete tomorrow? I would not suggest to revise NCRT per se. You can revise key points, summary points, and look at more questions rather than just NCRT. You can keep maybe half a day for NCRT or two time slots in the entire day for revising NCRT, but not complete NCRT, only the key points, summary points, key data points, key formulas, or like that. Apart from that, focus more on the reasoning part, reasoning questions, numericals. Many numericals were there last time. Okay, so keep all these things in mind. Case studies, assertion, reason, not assertion, reason per se, but statements and give reasons, and then MCQs. These are the things which you should be focusing more. Okay, try to solve more PYQs, sample papers, your mock test papers, everything. Okay, difficulty wise, see, there is no point guessing it because last year there was one set which was very difficult. Once or the remaining sets were moderate, one set was easy only. So it depends on your luck also, right? So the luck is bad, you might get the difficult set. People came out crying, if you remember last year, but other people are like, okay sir, it was fine. So it depends on the set which you are getting. Okay, a metallic wire coil is stationary in a non-uniform magnetic field. What is the EMF induced in the coil? Metallic wire is stationary. If it is stationary, no change in flux. No change in flux, no EMF. So no EMF will be introduced. Correct? Yes or no? Very good. Let's move on. Why does metallic piece become very hot when it is surrounded by coil carrying high frequency current? So if you have a metallic piece, if this is a metallic piece and there is a current, and this is basically AC current, what will happen? This AC current will give rise to magnetic fields. Magnetic fields which changes because current changes, field changes. Because magnetic field changes, flux changes. So because of that, in this metallic piece, you will see current loops which are called as eddy currents. Eddy currents which are created. So eddy currents, what will they do? They will create heat loss, I squared R losses. So I squared R loss, which is then generated as heat. So that's why this metallic piece will get heated up. Yeah, EMF is induced. Very good. Amazing. Moving on to the next one. Yeah, eddy currents are produced, which produces heating. If the rate of change of current is 2, EMF is 10, what is the self-inductance of the solenoid? Okay, let's think about it. Self-inductance of the solenoid, rate of change of current is given, EMF is given. EMF is L di by dt. That is the formula, magnitude wise. EMF is 10 millivolts, so 10 into 10 to the power minus 3. L is not known. L is not known. Di by dt is given 2 amperes per second. So 2 is there. So L will be 10 divided by 2 is 5. So 5 into 10 to the power minus 3. So that is 5 millihenry. That is the answer. Simple. Correct. 5 into 10 to the power negative 3, which is 5 millihenry. Cool, guys. Pakka. Done. Dusted. Awesome. 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 Let's go to the next question coming up on your screen. And here it is. Next 3 marks question. How is the mutual inductance of a pair of coils affected? Mutual inductance of a pair of coil affected when separation is increased, number of turns is increased, a thin iron sheet is placed between the coils, other factors remaining the same. Explain the answer in each case. So I'll give you the answer briefly. Okay. First of all, think when there are two coils, one coil will generate the field because of the current. That field will pass through the other coil. So the current is passed through one coil and that other coil is placed over here, across which EMF is generated. Now this coil, which is generating the magnetic field, is like this. Not all the magnetic field lines will pass through the second coil. Only a part of it will pass, and only that part which will pass through the second coil will create the flux, which will create the EMF. So let's think naturally what should happen. So if the separation between the coils, if it increases, then less field lines will pass. Obviously, if it was closer, more field lines will pass. So the mutual inductance will decrease because less flux will be linked. Okay. Number of turns. If you increase the number of turns, then naturally more flux will cut again and again through each coil. So mutual induction will increase. If you if you place a thin iron sheet between the coils, then iron is a ferromagnetic material. Ferromagnetic material means it will increase the magnetic field strength. So the field strength will increase, thereby increasing the flux. So thereby increasing the mutual induction. Correct. So it will increase, guys. Third is not decrease, it will increase. Yes. Decrease, increase, increase. Decrease, increase, increase. Not everyone gave the right answer, but I hope you got it now. Yeah, Akka? Just check. Shall we go ahead then? All right. Let's go to alternating current. Theory slides are there. So let's go to the first question on your screen. The RMS current is 5 amperes. Is the value of the current 1 by 300 seconds after it's become 0 is. So the current is going to go like this. The current will have an equation I naught sine omega naught t, which is I naught sine omega is 2 pi f and into t. Now, some time later, the current will become IRMS. The question is, what is the time then? So, IRMS is obviously I naught by root 2. So, I is I naught by root 2. I naught is as it is sine 2 pi frequency. Frequency is 50 multiplied by t. I naught cancels. So sine of 2 into 50 is 100. So 100 pi t is 1 by root 2. So sine of something is 1 by root 2. That means inside whatever is there is 45 degree. So 100 pi t is pi by 4. Pi cancels. So 100 t is 1 by 4. So t is 1 by 400th of a second. Oh, ho, ho. Sorry, guys. I understood the question only wrong. Question was not time. RMS current is given to me. Question is, after this much time, what is the, so sorry, after so much time, what is the value of the current? My bad. So if RMS is given to me, I know how much is I naught, because I naught by root 2 is RMS current, and RMS current is given to be 5. So I naught is 5 root 2. So now let's substitute and get the answer. Therefore, current will be I naught is 5 root 2, sine of 2 pi into frequency is 50 multiplied by the time, which is 1 by 300. Time was given to me. Okay, so 5 root 2. Now 0 cancels. So sine of, guys, 5 by 30 is 1 by 6. So 2 by 6 is pi by 3. Now what is sine of pi by 3? Sine of 60, guys. So sine 60 is root 3 by 2. So 5 root 2, and this is a root 3 by 2. So yeah, nothing else is there. So 5 root 2 will cancel. So you'll get root 3 by 2. So 5 and then root 3 by 2, which is option B. That's the correct answer. Correct? Yeah. Yeah. Very good. Very good. Many of you got option B as the right answer. Moving on to the next one. Resistance of 20 ohm is connected to a source of some voltage. The time taken by the current to change from its peak value to RMS value. Okay, from peak value to RMS value. So imagine now is the peak value, like this the current is going. Sometime later it becomes RMS value. This was the peak value. Question is, what time will it take? Now this kind of graph will be obviously a cosine graph. So current will be I naught cos omega t. So my current should become RMS. So RMS value is nothing but I naught by root 2. So instead of current, I will put I naught by root 2 is equal to I naught sine omega. Huh. Omega is 100 pi. 100 pi. No, sorry, this will not be sine, this will be cos. So cos 100 pi t. I naught will cancel. So cos of 100 pi t is 1 by root 2. Whose cos is 1 by root 2? When the angle is 45 degree. Pi will cancel. So 100 t is 1 by 4. So time will be 1 by 400 of a second. So 1 by 400. So 1 by 4 is 0.25. So into 10 to the power minus 2. So if you want, you can write this as 2.5 into 10 to the power minus 3 seconds. So 2.5 into 10 to the power minus 3 is option A. Straightforward. Yeah, very good. Last few questions, guys, because we are already on AC, there is only one more chapter remaining, which is which is electromagnetic waves. RMS value of the current is related to the peak current. I mean, this is simple. RMS is maximum by root 2. So I think it is directly option D. Very straightforward question. Usually they will not ask, but Chumma give it to you like a boosting question, confidence booster. In a AC circuit with voltage V and current I, the power dissipated is, very good. Power in AC is Vrms, Irms multiplied by cos phi. Phi is the phase difference. The phase difference. So definitely depends on that. It's not this or this. It is definitely option D. Yes, many students make that mistake. Jacob, which part you did not understand? Please let me know. I'll help you out with that. In the previous question, you mean? In this question, see, already they gave the equation, current or voltage, whatever it is some cost function. Why cost function? Because we have to measure from peak value. So which periodic function starts from maximum value? Sine starts from 0, cos starts from maximum. So I took the cost function. Now you have to reach the maximum to RMS value. How much time it takes? So this value should become RMS. RMS means this by root 2. Yeah, standard. This by root 2, maximum by root 2. So instead of that current, I have put maximum by root 2. I naught cancelled. So this should be 1 by root 2 because root 2 has remained. Now whose cos is 1 by root 2? Cos 45. But never put degrees, always use radians. So pi by 4 radians. pi got cancelled. So 100t is 1 by 4. So 100, if you take it below, it will become 1 by 400. But what is 1 by 4? 0.25. So 1 by 100 is 10 raised to negative 2. So if I shift the decimal, it will become 2.5 10 to the power minus 3. That's all. Okay. So I just, instead of, using a sine function, I use cosine function because cos value starts from maximum. Does that make sense? All right. Moving on to the next one on your screen. Power factor of a AC circuit is 0.5. What will be the phase difference between voltage and current in the circuit? Come on, guys. Power factor is given. Power factor is given. The question is, what is the phase difference between them? So power factor means cos phi. Cos phi is 0.5. That means it is half. So whose cos is half? 60 degrees. So the angle between voltage and current is 60 degrees. Angle between voltage and current is 60 degrees. Pi by 3. Yes, that is the right answer. Very good. Come on, guys. Spam the answers because last few questions coming up on your screen now. Weber is the unit of which physical quantity and hence define it. Weber is for flux and flux is magnetic field into area. Okay, it is a magnetic field and area's multiplication. So it is B dot A. Yes, Weber is the SI unit of magnetic flux. It is the flux that links through one turn would produce when 1 volt were created to 0 in uniform rate and 1 second. So basically what happens is the way flux you define it, 1 unit of flux is, see, EMF is defined as rate of change of flux, right? EMF is rate of change of flux. So if you create 1 volt in 1 second, the flux is 1 Weber. So that's how you define it. So when you are generating 1 volt of EMF, when the flux is reduced by 1 Weber, then in time of 1 interval, that flux is basically 1 Weber. Yeah, that's it. Moving on to the next question on your screen. Here it is. Magnet is moved in the direction indicated by an arrow between two coils AB and CD as shown in the figure. Suggest the direction of the current in each coil. I think the diagram is missing. I'll directly go to the solution slide. Something is wrong. Okay, I will just make up some question and I'll just show it to you. What should be the actual answer? Maybe this is coil AB and this is coil CD, and maybe that magnet which is moved, okay, maybe it is like this. Chumma I'm taking. Let's say this is south, this is north, and let's say you move it like this. Okay, Chumma I'm drawing some diagram like this. Okay. Now what happens is when you move this magnet towards this coil, when you move this magnet towards this coil AB, you will see more flux, more flux, more flux will be there in this coil because more lines will pierce through this in this direction. So to oppose that, the opposing flux, so the induced flux will oppose it in this direction. So to create the flux in this direction, you will have to make the current go in this direction. Use your right hand rule. The flux is in this direction, right hand thumb is this way. So the current will go like this. So that is the direction of the current. Whereas if you consider the coil CD, because this magnet is moving far away, then you can clearly see, because this magnet will be creating magnetic field lines like this. So the flux which is in this direction will reduce. So the flux in this direction is reducing. So to oppose that change, the induced flux strengthens it in this direction. So the induced flux is in this direction. So this direction you should place your thumb. Your fingers will curl like this. Your fingers will curl like this. So the induced current will be in this direction. That's how you can get the direction of the current in any coil. Okay, I hope this is clear. You have to use right hand rule and always think, if the flux is increasing, how can I reduce it? If the flux is reducing, how can I increase it? Okay, so you should know which direction the flux is going. So either you strengthen it or weaken it depending on whatever is happening exactly opposite to it. Always. Okay, cool. Shall we go ahead to the next one? All right, let's go, let's go, let's go. What is it? Next one. Hmm. A variable frequency connected across series combination LCR, calculate angular frequency which the circuit is in resonance. For this, which formula will you use? Omega is 1 by root LC, L is given, C is given. Impedance of the circuit, uh, impedance of the circuit to connected to a series LCR. Impedance of the circuit will always be the resistance in case of resonance. Amplitude of the current in resonance, current amplitude will be just voltage by impedance, but impedance is a resistance. So voltage is already 230 and resistance is 40. Okay, so 230 by 40, but this will be RMS current. So the peak current will be IRMS multiplied by root 2. So whatever answer you get, you have to multiply it by root 2. So 230 by 40 multiplied by root 2 will be the amplitude of the current, because this voltage, remember, is RMS voltage. So that's it. That is how you solve it. In the next slide, we have done all these things. All right. Next. No, LC oscillations is not there. Okay. Electromagnetic waves. Electromagnetic waves. Let's go. EM waves. First question on your screen. If Vs, Vx, Vm are the speeds of soft gamma rays, X-rays and microwaves in vacuum, then compare that quantities. Yes, I will try to conduct it in the first half or second half early only. In the afternoon only, we'll try to do it. Okay. We'll try to complete it in the afternoon as much as possible. Yeah. I'll be sharing the slides. Kevin's Zone King, definitely. Okay. Arvinda Narsimha Murthy. Yeah. We'll try to, not morning, but early afternoon or something like that. We'll try to do it as much as possible. If Vs, Vx and Vm are the speeds of soft gamma rays, X-rays and microwaves respectively in vacuum, guys, the speeds are always equal. It doesn't matter which electromagnetic wave you use. All the electromagnetic waves will travel with the same speed. Yes, frequency and wavelengths are different. Correct. It's a trick question. It's a trap question. Which of the following is infrared wavelength? 10 raised to minus 4, 10 raised to 5 is very long. So no. Minus 6, minus 7. Centimeter means 10 raised to minus 2. So this will become 10 raised to minus 9 meter. So this is like nanometer. This is out of question. This is like 10 raised to minus 8 meter, which is, yeah, a centimeter means 10 raised to minus 2. So minus 6, minus 2, minus 8. So this will be basically 10 nanometer. This is also out of question. What about this? This is also out of question. So this only, which is basically 10 raised to minus 6 meter. Yes, it is micrometer. Micrometer, around that range. Yes, you should get, infrared rays. Pakka? Yeah, everyone? Option A? Awesome. Sir, I have some doubts, sir. How can I reach you? Maybe you can ping me on Telegram or Instagram. I try to respond to as many messages as possible, but I can't guarantee. I'll try to see, man, if I can respond to your messages. Captain Shreyas, you can search for me. Better Telegram will be better, or Instagram also. Which of the following type of radiations are radiated by an oscillating electric charge? If we take an electric charge and move it up and down, the electric fields will change. Accordingly, magnetic fields will be induced. So an electromagnetic wave will be created. So the answer is electromagnetic. Correct? Everyone? Yes, very good. Option D. Very nice. Next, the speed of electromagnetic waves in vacuum depends on the source of radiation. It increases. As you move for gamma to radio, decreases. It, no, guys, it will not be different. In fact, it is the same speed. Look at the question. The speed will be the same. The speed will not change. Okay, the speed will depend not actually on the source, but also depends on the medium in which it is traveling. So as long as the medium is same, the speeds will be the same. Yes, option number C. Very good. Proud of all of you. The charging current for a capacitor is this much. What is the displacement current? Now, if a current is passing through a capacitor, this is your conduction current, and in between the plates there is no physical current, but there is displacement current, and always displacement current happens to be equal to the conduction current which is connected to it. So this will be also 0.25 amperes only. Yeah, it is exactly the same. All right, next one. Write the following radiations in descending order of frequency: red light, x-rays, microwaves, and radio waves. Radio waves are very long wavelength. Microwaves little bit short. Then red light is even shorter, and X-rays are the shortest. So frequency wise, highest will be X-rays. Then you will have red. Then you will have microwaves, and then you will have radio waves. This is frequency I'm talking about, because frequency is inversely proportional to wavelength. Yeah? Radio waves are the longest, so smallest frequency. X-rays are the shortest wavelengths, one of the in this category. So largest largest frequency. So X-rays are very energetic. Remember that X-ray, red, micro, and then radio waves. Yes, perfect. Many of you gave the correct answer, as I can see. Very good, very good, very good, very good. Let's move on to the next one. X-rays, red, micro, radio. X-rays, red, micro, radio. Perfect. Let's move on. Write the application of infrared radiations. There are many applications. Just write 2 applications in the chat box. In short, many applications are there. Many applications are there. Infrared rays. In COVID times, they used to use thermal scanners. Remember, they were based on infrared rays. Your body generates infrared radiation that is sensed by those thermal scanners, and they can detect what body temperature you have. So thermal scanners to measure body temperature is one good application. Any other application? Have you seen army people use those infrared goggles to see if there is a terrorist or infiltrator, because body generates heat signatures. So to detect some terrorist or infiltrators, the army people, they use infrared vision cameras. Correct. Very good. Your AC remote or TV remote, like this one, where did my remote go? This one. Yeah. Do you see this remote? This has some LED over here. This is generating light which is in infrared range, and it communicates to my AC. Same way your TV remote also. Yeah? So that also is basically, yeah, infrared. Greenhouse is not an application. Greenhouse is a phenomena. It's a natural thing. We are not creating it artificially for some purpose. It is just as a consequence, as a phenomena. So don't write greenhouse. Yes, infrared rays are involved in the greenhouse effect, but it's not an application. Be careful. Yeah, it is also used in medical therapy and all of that. Yes, definitely. Right. So there are many applications. I have put it up over here. I have told you few of them, but yes, medical treatment, heat treatment, infrared spectroscopy for chemical analysis, you use it. Remote controls, infrared radiation, secret writings in ancient walls, even for taking photographs in foggy conditions because of the heat signatures. So multiple applications you can write. Okay. The electric field oscillates frequency and amplitude. What is the wavelength, amplitude, average energy density? Come on, direct formula based. Why is it called heat waves? The reason why it is called as heat waves is because if you remember from 11th standard, there was this law called as Wien's displacement law. There is one particular wavelength which is emitted the most at one particular temperature. That graph goes up and down like a bell curve. So as the temperature increases, wavelength reduces and all of that. So if you take a room temperature of 300 Kelvin, which is your regular body temperature range, then the wavelength which comes out is in the range of infrared. So that is why it is also called as heat waves, because we are warm-blooded animals, and warm-blooded animals emit infrared radiation in that particular range at 300 Kelvin, which can be detected. But cold-blooded animals will not emit that much infrared radiation. because of lack of that body heat. That is why we also called infrared as heat wave or heat detecting radiation. Yeah. So what formulas will you use? Yes, just telling you the formulas. E by B is equal to C. So from that you can calculate magnetic field as E divided by C. This is one formula for this one. Then for wavelength, yes, C is equal to F lambda. So lambda is equal to C by your F. So wavelength, because frequency is known, speed of light is your 310 to the power 8. What else? For electrical energy, average energy density of the electromagnetic field, that is half epsilon naught E square. Electric field is known, epsilon naught is also known. So from that, you can calculate C also. That is what you have to do. Yes, wavelength, magnetic field, and half epsilon naught E square. Same thing. Yeah, exactly. All right. Yeah. So that was your questions. I'll be sharing the slides with you. Tomorrow we will do a different kind of revision, although we'll be doing it for part 2. I'll try to conduct 2 sessions, but tomorrow part 2 will just do questions to the point. I'll keep the theory for your quick revision. Immediately after the session, I'll be sharing that PDF so that you can revise quickly. But worst, either in the night or early morning, we'll do a quick revision. Okay. So tomorrow we'll try to conduct the part 2 somewhere in the afternoon, and then maybe one more session I'll try to take where we can do some more important questions or some challenging questions, some aptitude concept based questions which can come. Okay, so those difficult questions, because CBSE can give those kind of questions as well. All right, cool. So I hope you found this session useful. Thank you for liking the video. Thank you for sharing the video, and let me know in the comments what exactly do you need tomorrow. Accordingly, I will plan. Part 2 is so 100%, but if you want some competitive aptitude based questions or anything else, please let me know, because tomorrow is the final day. Even though I can come in the morning just on the day of examination, but I don't want to pressurize you guys too much. All right, so I want you to sleep peacefully on the exam day. Okay, if you need some strategy or how to attempt the paper, that video, that also I can take. Okay, let me know. Thank you so much. God bless you all.